guys are going to for paper 4 on Wednesday, and listen, I know that paper 2 is a little bit different. And what I'm going to do is I'm just going to look at things in paper 4 that the examiners could now take advantage of after we knew what happened in paper 2, and now that they know that you have a calculator. Some of the things that you should sharpen up. So the first thing that could come up quite a bit is cubic functions, right? They could take advantage of the fact because most cubics don't factorize properly. They could take advantage of the fact that you have a calculator work out certain numbers and certain turning points in doing this over here. Because the main thing that you're going to be able to do now with the calculators that you weren't able to maximize to its full extent in the previous paper is the quadratic formula. I'm going to show you how that's going to affect things, right? So the first thing could be something of the form of here, where we say sketch function of x cubed minus 2x squared minus 11x plus 12 in the range minus 3 to 4. Now, typically they make this pretty easy for you because they give you a little table of all of your input x values and ask you to find your output y values. Right? You'll throw it in your calculator, use your table functions, type in all the values, get your outputs, and it's a free 2 marks generally, right? If they don't, use this as your starting point and then use increments of 2 or whatever you find fit to try and get to the end point over there, right? But generally this will already be done for you in your tutorial mode. After filling out the function, take note of your roots, okay? Where is something rooted, okay? I've seen a couple of papers where they factorize the function for you and make it equal to 0. In that case, each factor, when it equals to 0, becomes a root. But here we've got our 3 roots, so we put down our roots, right? Then carefully plot and show where you're plotting all of your other points. In this case, I've got minus 1 is 20 and 2 is minus 10. Do not, under any circumstances, estimate your turning point. That's going to get you into huge trouble. What you're going to do to find your turning point over here, I'll put it as TP down here, of a cubic function is take the first differential. This will give you the quadratic to the power of 2 function. Use your quadratic formula to then find the 2x values. In this case, after solving this quadratic formula over here like I did, I got minus 1.35 and p.1 to be my solutions. Those are my 2 turning points, right? Sub these back into the equation to find out which one of these turning points is higher and which one is lower, so you know your maximum and your minimum, and there you have your graph like this over here. Now, a couple of tricks that we can use with our cubic over here is, okay, so sorry, just I think if I mentioned, this must be equal to 0, and that's how you do your quadratic formula, okay? But you should be comfortable with this. One thing I want you to know with your cubic when sketching your cubic function is that your cubic function, if your coefficient of x to the power 3 of the degree is positive, your cubic function will start lower and go higher, right? If your cubic function is negative, we're going to have a function that would start up here and come down this way over here like that. So that's just something for you to keep at the back of your mind if you're starting to draw them. Also, they do not need to always be 2 defined turning points in a cubic function. We do have cubic functions that look something like, I'm sorry for the space, but we do have cubic functions that look something like this over here. And we also have got cubic functions that just are monotonous all the way through like that over there, right? Okay, there's a video that I put out on how to find whether these functions are like this. I'll link it below. But as a general rule, make sure you find your roots, because once you get your roots, you get an idea of where the graph is heading. And after you find your roots, make sure you get your turning points, sketches, game over. Now, a follow-up question to the cubics is graphing and tangents, right? So they could ask a question like x to the 3 minus 2x squared is equal to 10x plus 3 as a follow-up to this question over here on my cubics. Now, the big issue that we're going to have over here is that you need to manipulate this such that you can use your graph to determine the answer, right? I've shown you guys how to do it. We have x cubed minus 2x squared is equal to 10x plus 3, okay? I need to get this back. So I need to get this guy over here back in. I need to get him back because that will help me use this graph over here. So what I'm going to do is I'm going to bring everything to one side, make this thing equal to 0, and see, okay, what needs to be put on this side over here? What do I need to add on this side over here to be able to use this graph in order to solve this equation? And what you will find out is that what we need to actually add on this side over here is we have minus 10x here, and here we have minus 11x, so I must minus another x on here, which means I have to minus another x on this side, so I put a minus x. Then on this side I've got minus 3, but for my graph I've got plus 12. So I need to add 15 on this side over here, which means I have to add 15 here. So we get minus x plus 15. And I've got back my original function over here, but I now know that it's equal to a straight line minus x plus 15. So what you'll do is very, very carefully go to your thing, your plot over here, put minus x plus 15. You will plot it through like this over here, and very carefully read off the points where and if it intersects your graph. Is that making sense? I'm hoping that this does make some sense. Okay, so now let's talk about how we find tangents. Okay, if they asked us what is the tangent or the equation of a tangent x is equal to 2. Well, dy over dx, again, it's very important to understand that dy over dx is a gradient formula. So it tells you the gradients at any one point in the graph if you sub in the x value. So if I sub in 2 into this formula, dy over dx, which I got from taking the first differential of this function over here, I'm sure you guys are all okay with the differential rule. To get the first differential, you have to just drop this and subtract 1. So 3 times 1 is 3. 3 minus 1 is 2. Then 2 times minus 2 is minus 4. Minus 1 there just gives me a 1. And then 1 times minus 11 is just minus 11. 1 minus 0 is 0, so the x goes away over here. So I've got my dy over dx over here. I can work out that at 2, if I sub 2, I get the gradient at that point. And I get the gradient of the point of 2 to be minus 7. So my line that goes through has to have gradient minus 7. So that's to be y is equal to minus 7x plus c. What will be very nice in these questions is that you mostly will have that 2 in the table over here. So we know that when we have x as 2, y is minus 10. And because that's the values in the function, your tangent touches the function at that point, and this also be the values of your tangent. So you sub it back into here, you say, okay, minus 10 goes into my y, x goes into my, 2 goes into my x, I find c is equal to 4, the equation of the tangent is minus 7x plus 4. So if you draw a line of minus 7x plus 4 at 2, you will end up into, minus 7x plus 4 at 2, you will end up touching the graph at that point. Okay, let's have a look at our trig. Now, for trig, the main thing I could come up is your cost diagram, okay? There will be some equations. I just want to make sure. I know that there was a tan equation in the first paper. Here, there could be other equations where they need you to choose the application of your cost diagram, even in your 2D trig sine cos. So we have here 3 sine x is minus 2. You can get sine x equal to minus 2 over 3. Inverse function sine the minus 2 over 3 is equal to x. We get negative 41.81 degrees. Sorry if I'm going a bit fast, but this is not supposed to be a video where I'm teaching you. I'm just recapping some things with you guys, okay? Because you got minus 41.81, a lot of the times, these questions say that they want the answer to be in the range of 0 to 360 degrees, which is fine. Because this is outside that range, so we're going to say fine. It's a negative 41.81. We'll use 41.81 as our reference angle. Because it was negative, we're looking for the 2 quadrants where sine was negative. That is the 3rd quadrant and the 4th quadrant. And we use that as our reference. So here we say 180 plus the 41.81, 180 degrees plus 41.81 will give me this as my answer. Whereas here, I will say 360 degrees minus my reference angle of 41.81 will give me 318.19 degrees. Please get comfortable with your cost diagram. Then they say if cos theta is equal to negative 1 over 2. Now, sorry, just to come back to your cost diagram, there are other ways. There's a graphical method to do this as well. I'm using the reference angle method because if you're struggling with it and you're 2 days out, most probably easiest method for you to know. If cos theta is equal to minus 1 over 2, I'm going to give you another example here. You will get theta in your calculator when you say shift cos of negative 1 over 2, you'll get 120 degrees. The problem with that is that only gives you the answer here. If you have cos, remember that the cos graph, I don't have space here. Just remember that your cosine graph very, very quickly, I hope you can see over there, right? It is what we call symmetrical about the y-axis. So if positive 120 degrees is a solution, let's say somewhere over here, right? If positive 120 degrees is a solution over there, negative 120 will also be a solution. So all we're going to do is we're going to say that another solution is negative 120 degrees, but it's outside our range. So we add 360 to bring it into our range, and we get 240 degrees to be our second answer. For sine and cos, there's always going to be 2 answers that you need to look for, whereas for tan, you can just apply the reduction formula because the period is 180 degrees. Okay, functions. Please remember we have reciprocal and exponential functions. I know the play isn't that they always ask it, but I'm just saying they've been doing different things, okay? For your reciprocal function, your asymptote, vertical asymptote is whatever makes a 0, so in this case, positive 3. Your horizontal asymptote is whatever's on the outside, so in this case, positive 4 on the y-axis. Put those in, get your, make this 0 over here so you can get your y-intercept, make this whole thing 0 so you can get your x-intercept. Remember that for functions in general. And then once you calculate that, sketch the graph through there. If it is a reciprocal function and your a is positive, you will have your function will be on quadrants 1, quadrants 3 after the shift, and this one will be 2 and 4. I hope you're very, very comfortable with that. Exponential function, same thing. Remember, you've only got a horizontal asymptote over here, so get that in. It's just number on the outside. And then for the rest of it, remember to get your x and your y-intercept. Well, in this case, you're just going to make x 0. If you make x 0, you get 2 to the power 0 is 1, minus 1 will be 0. And if you take this over to the side over here to get your y-intercept by making this 0, you're going to get 2 to the power of x equal to 1, which also gives you 0. So you're going to be very, very safe there. Put this through. Basic things to remember. Now, the one thing I think they could play is a parabola and a straight line. They want to play this. It's more an AS level topic, but they're looking to play. I'm telling you now, I think quadratics will be a huge part of tomorrow's paper, or Wednesday's paper. Okay, you got f of x equal to x squared minus 4, whereas g of x is equal to 2x plus 1. They ask you to find the x value of f of x is equal to g negative 1x. They could ask in many different ways, or ask for the intersection. Intersection means finding whether the two graphs are equivalent to each other, but it's f of x equal to the inverse of g of x. It's important that if you need to find the inverse of a straight line and use that straight line, You find the inverse by making x, switching x and y, and making y subject to the formula again. But don't leave it like that. Write it out as x over 2 or half x minus 1 over 2 over here at the bottom. This over here will help you a lot. And what I'm telling you is that when you make it equal, I've ran out of space here. I've done it all up here. I'm going to hold this very still. When you try and equate this to the parabola, it's going to be a lot easier if you have it in this form over here and bring it all over to one side. So you can get your standard form quadratic equation equal to 0 and then use your quadratic formula to solve for here. It will be a lot easier than if you leave it like this over here. That's just something that I think you must be comfortable with, is using the quadratic formula in any form, getting your things into standard form in any form, getting plain standard form in any form. So I think it's going to be a big play coming up. Next video, I'll look at some stats, probability, sine rule, cos rule, and some vectors, which I think will also be quite big. And I do think that this will become a recurring theme that you need to understand your quadratics. But it's been something they've been playing on in the past few years. Okay, again, guessing mainly, but I hope that these little tricks will help you at some point. Enjoy. If you need any help, get in contact. I'll see you in the next one.